The lines L1 and L2 have equations here and here, respectively. Show that L1 and L2 are skew. Find the acute angle between L1 and L2. The point A lies on L1 and OA is perpendicular to L1, where O is the origin. Find the position vector of A. Okay, so I've got it all summarized here. So let's have a look at this problem then. Show that L1 and L2 are skew first of all then. So for part 1 then. So for them to meet we need 4 plus 3s. Here for them to intersect we need 4 plus 3s to be equal to 1 plus no t's, so it's just 1. And that tells us what s is straight away. S needs to be 1 minus 4. 3s is equal to 1 minus 4, which equals minus 3. And that tells us s is going to be minus 3 over 3, isn't it? Move the 3 from times to divide. And that's equal to minus 1. That's from 1. Also we need to have the y coordinates being the same. So 6 plus 2s then. And 6 plus 2s needs to equal 0 plus 1t. 0 plus 1t is just t. So that tells us that because s is minus 1, we can put it in here, and that tells us that t needs to equal 6 minus 2 is 4. So there's t, and here's s. Now let's check the z component to see if the lines are skew or whether they intersect. So here, what have we got then? We've got 4 plus s. 4 plus s on the one line needs to equal, on the other line it's minus t. 4 plus s is minus 1 is 3, equals, and minus t is minus 4, which is not true. So lines do not intersect. So lines are skew. Or skewed or askew. The lines are skew. Right, that's the first one then. Find the acute angle between L1 and L2. So our directional vectors are 3, 2, 1. And this directional vector is 0, 1, minus 1. So let's take them with us. These are the two directional vectors. So let's take them down below, and we'll just work on those then. For part 2, we need to find out the angle, don't we? So this is part 2. Here, the dot product then first of all, which we need to get the angle. 3 times 0 is 0, 2 times 1 is 2, 1 times minus 1 is minus 1, so we get 1. The moduli of these component directional vectors, let's label this one A and this one B. So A is equal to the square root of the first component squared, the second component squared, plus the third component squared. 9, 10, 14, square root of 14. The modulus of b, on the other hand, would be the square root of, it's 0 squared, 1 squared, and then minus 1 squared. So we end up with root 2, don't we? So the angle then, we know from the formula that A dot B is equal to modulus of A, modulus of B, cosine theta, the angle between them. This is the cosine formula. So because of that, then we can write down, cosine theta then, the angle between them, will be the A dot B here, which is 1, divided by, move these 2 underneath now, root 2 times root 14. So theta then is equal to shift cos of this. So shift cos of 1 divided by bracket square root of 2 outside the square root times square root of 14 outside the square root, close that square root product bracket, close the cosine bracket, 79.1 degrees. So it's 79.1 ... degrees. So theta is approximately equal to then 79 degrees to the nearest degree. So that's the angle between the two lines, and it's acute, isn't it? So we've done part 2. Part 3, A lies on L1 and OA. So the coordinates of A then, right, the coordinates of A lies on L1. So, okay, 4 plus 3s, OA is, as a vector, it's 4 plus 3s. And the next component, if it lies on L1, will be 6 plus 2s, and then 4 plus 1s. 6 plus 2s and 4 plus 1s. Let's put them both down, and 4 plus 1s. So there's our vector for OA from the first piece of information. So let's go on to the next one. And OA is perpendicular to L1. So dot L1, so dot 3, 2, 1, perpendicular. And OA, 4 plus the 3s, 6 plus 2s and 4 plus s is perpendicular to the 3, 2, 1 of line L1. So that was the next piece of information, wasn't it? Okay, so that would dot product cosine of the angle then is 90 and cos 90 is 0. So when they're perpendicular, the dot product is 0. So that tells us then, what do we get here? It tells us that 3 times this, so I'm going to put it up here, 12 plus 9s for the first product, because 3 times these two. 2 times these two is 12 plus 4s. And 1 times this one, 4 plus s. That all equals 0. So we've got 12, 24, and 9 is 33. 12, 24, and 9. Oh, this is an s here, so it's 12, 24, and 4. Sorry. 24 and 4 is 28. 9s, that was these 3 numbers. 9s plus 4s plus s. 10s, 14s plus 14s equals 0. That's what we've got there. So s will equal, so that tells us now 14s, leave it as is, move the 28 to minus 28 on the other side, move the 14 from times to divide, and we get s equals to minus 2. So the coordinates OA as a vector then is equal to, but s is minus 2 in here, 4 minus 6 is minus 2. 6 minus 4 is 2, and 4 plus minus 2 is also 2. Minus 2, 2, 2 for the vector OA.